A quadratic equation is an equation of the form ax squared plus bx plus c is equals to 0, where a is not equals to 0. Dividing both sides of this equation by the coefficient of x squared as I will have ax squared over a plus bx over a plus c over a is equals to 0 over a cancel a here, then I'll be left with x squared plus bx over a plus c over a is equals to 0, since 0 divided by any number is always 0. Let's call this equation 1. Let's say the solution of equation 1 are x equals to alpha or x equals to beta. X equals to alpha means x minus alpha is equals to 0 is a root, or x minus beta is equals to 0 is another root of equation 1. That means x minus alpha times x minus beta is equals to 0. Multiplying out, I'm going to have x times x minus beta minus alpha times x minus beta, which is going to give me x squared, that's x times x is x squared, minus x beta minus alpha x, that's minus alpha times x minus alpha x, minus times minus plus alpha beta is equals to 0. That means factorizing negative x in these two terms, I am going to have x squared minus x into alpha plus alpha beta is equals to 0. That is, arranging it to look like the general equation of a quadratic, I'll have x squared minus alpha plus beta x plus alpha beta is equals to 0. Comparing this equation with equation 1, alpha plus beta will be equals to b over a, that's negative b over a. Alpha beta will be equals to c over a. These two formulas are very useful. You also know that alpha plus beta all squared can be expanded as alpha squared plus 2 alpha beta plus beta squared. This expansion is done following the Pascal triangle principle and the binomial theorem. As you can see, the powers of alpha are decreasing and the powers of beta are increasing. The coefficients of the terms here are gotten using the Pascal triangle. That is, we have 1 1 1 2 1 1 3 3 1. This is first expansion, second expansion, third expansion. That's expansion to the power 1, power 2 and power 3. So here we are doing expansion to the power 3. So the power of alpha started with 2 and it drops to 1, and the coefficient of alpha squared is 1. For the middle term the coefficient is 2, and for the last term the coefficient is 1. And the powers of beta started with b to the beta to the power 0 and increased to 1 and then to 2. From here, alpha squared plus beta squared can be made the subject of the equation as alpha squared plus beta squared will be equals to alpha plus beta all squared minus 2 alpha beta. This is also a very important formula to be noted. Carrying the expansion of alpha plus beta cube using the binomial theorem, we can also get alpha cube plus beta cube equals to alpha plus beta all cube minus 3 alpha beta into alpha plus beta. Carrying similar expansion using the binomial theorem and the Pascal triangle principle, we can also obtain alpha cube minus beta cube is equal to alpha minus beta into alpha plus beta squared minus 3 alpha beta. From the expansion of alpha minus beta squared, alpha minus beta squared can be obtained as alpha plus beta all squared minus 4 alpha beta. These formulas in boxes are very useful in carrying out calculations that involve coefficients of quadratic equations and their roots. Let's do some examples. The quadratic equation x squared plus 5x plus 2 equals to 0 has roots alpha and beta. Find the values of alpha plus beta, beta plus 2, alpha squared plus beta squared, 1 over alpha squared plus 1 over beta squared. To look for the values of these expressions, we need to first of all find the values of alpha plus beta, alpha times beta of this quadratic equation. Comparing this quadratic equation to the general form of the quadratic equation ax squared plus bx plus c equals to 0, we'll see that a is equals to 1, b is equals to 5, c is equals to 2. We know the formula of alpha plus beta is equals to negative b over a. So that means alpha plus beta is equals to negative b is 5, that will be negative 5 over a, which is 1. That means alpha plus beta is equals to negative 5. Now the formula for alpha times beta is equals to c over a. That means alpha beta is equals to 2 over 1, which is equals to 2. In the a part, we are required to look for the value of alpha plus 2 times beta plus 2. We need to multiply this out so that we should have this expression in terms of alpha plus beta and alpha beta. Alpha times beta plus 2 times beta plus 2. Multiplying this out, I'm going to have alpha beta plus 2 alpha plus 2 beta plus 4. I need to arrange it to look like alpha beta, alpha plus beta. Here is alpha beta. Now I have 2 alpha plus 2 beta. I want to factorize out 2. I have alpha plus beta plus 4. So I've gotten the expression in terms of alpha beta, alpha plus beta. You know, alpha beta is 2 plus 2 into alpha plus beta, which is minus 5 plus 4. 2 times minus 5 is minus 10. So I'm going to have 2 minus 10 plus 4. 2 minus 10 is minus 8. Minus 8 plus 4 is equals to minus 4. That means alpha plus 2 beta plus 2 is equals to minus 4. B, we are required to look for the values of alpha squared plus beta squared. You know, previously we just obtained the values of alpha squared plus beta squared to be alpha plus beta all squared minus 2 alpha beta. In this expression, to obtain alpha squared plus beta squared, I will now substitute the value of alpha plus beta in the place of alpha plus beta and alpha beta here. That is going to give me negative 5 squared minus 2 into 2. Negative 5 squared is plus 5 squared is 25. Minus 2 times 2 is negative 4. 25 minus 4 is 21. Therefore, alpha squared plus beta squared is equals to 21. See, we need to look for the value of 1 over alpha squared plus 1 over beta squared. We need to express this in terms of alpha plus beta and then alpha beta. To do this, let us look for the LCM. Here the LCM will be the product of alpha squared beta squared. Alpha squared goes to alpha squared beta times beta squared times 1 is beta squared. Beta squared goes here, alpha squared times 1 is alpha squared, which is equals to beta squared plus alpha squared all over alpha squared beta squared. Beta squared plus alpha squared is the same like alpha squared plus beta squared, and then alpha squared beta squared is the same like alpha beta all squared. From the B part of the question, I just obtained the value of alpha squared plus beta squared as 21. I may have 21 over alpha beta, which is 2, that's 2 squared, which is the same like 21 over 4. That means the value of 1 over alpha squared plus 1 over beta squared is equals to 21 all over 4. More examples. The roots of the quadratic equation x squared minus 3x plus 5 equals to 0 are alpha and beta. Form quadratic equations whose roots are a alpha minus 1 and beta minus 1, b alpha squared and beta squared. So to form new quadratic equation, the first step we need to take is to look for sum of roots and product of roots of this equation given. Comparing this equation to the general equation of a quadratic equation, we have ax squared plus bx plus c equals to 0. We see that from this equation, the coefficient of x squared is 1, so a is equals to 1. The coefficient of x is minus 3, so b is equals to minus 3. And the value of c here is plus 5. It means c is equals to 5. Alpha plus beta is equals to negative b over a. Our b is negative 3, so it means we are going to have negative into negative 3. That's, we put negative 3 in the place of b, all over 1. Negative times negative is positive, so alpha plus beta is equals to 3 over 1, which is the same like 3. Alpha beta is equals to c over a. C given to us is 5 and a is 1, so we have 5 over 1, which is the same like 5. That means alpha beta is equals to 5. Note that the formula to obtain a new quadratic equation is of the form x squared minus sx plus p is equals to 0, where s here stand for sum of roots and p stand for products of roots. We will use this formula to obtain the new quadratic equation. The roots of the equation we are required to form are given as alpha minus 1, beta minus 1. The first step is to look for the sum of these roots. Since we already have alpha beta and alpha plus beta from the whole equation, we need to look for the sum of root of this equation, expressing it in terms of either alpha beta, or alpha plus beta and alpha beta, so that we can be able to have the value of the sum of roots here and the product of roots here. Alpha minus 1 plus beta minus 1 is the sum of root. So expressing it in terms of alpha and beta, I'm going to have alpha plus beta minus 1 plus minus 1. So minus 1 plus minus 1 is minus 2. So I'm going to have alpha plus beta minus 2. But I know alpha plus beta is equals to 3. So that will be equals to 3 minus 2, which is equals to 1. So it means the sum of roots is 1. So the product of root is alpha minus 1 times beta minus 1, which is the same like alpha times beta minus 1 minus 1 times beta minus 1, which is the same like alpha beta minus alpha minus beta plus 1, which is the same like alpha beta minus into alpha plus beta. So I open this, I'm going to have this plus 1, but our alpha plus beta was 3 and our alpha beta was 5. So here I have 5 minus 3 plus 1, which is the same like 2 plus 1, 3. So it means product of root is 3. So the new equation will be x squared minus sum of roots times x squared minus sum of root, which is 1, that's minus 1x plus product of root, which is 3, plus 3 is equals to 0. That is x squared minus x plus 3 is equals to 0 is the new equation. B, form quadratic equation whose roots are alpha squared and beta squared. So as I did in the A part, I need to look for sum of roots, which is alpha squared plus beta squared. And previously we know that alpha squared plus beta squared is the same like alpha plus beta squared minus 2 alpha beta. Our alpha plus beta squared of this equation was 3. That's 3 squared minus alpha beta, which was 5, as 2 times 5, which is the same like 9 minus 10, which is equals to negative 1. So sum of roots is negative 1. Product of roots, that is alpha squared times beta squared, is the same like alpha beta all squared. Or alpha beta that we got from the old equation was 5. So this will be the same like 5 squared, which is the same like 25. So it means that product of root is 25. Now we need to form the new equation. The new equation is x squared minus sum of root times x. Sum of root is minus 1. So in the place of sum of root or s, I'm going to put minus 1. That's into minus 1 x plus product of root, which is 25. That's plus 25 is equals to 0. Minus times minus is plus. So the equation will be x squared plus x plus 25 is equals to 0. It means the new equation is this.